Hi dear students, welcome to the next topic from electric charges and electric field, which is called electric flux. Okay, so we are just going to learn some new things, whatever we have learned so far, which is related with electric dipole. So electric dipole session is over. This is a little bit a new topic which is called electric flux. Here we will learn one of the major law called Gauss's law. Okay, so that is very important, especially for your board examination point of view as well as for the entrance examination point of view. So let's start with electric flux. Before going to flexor, I would like to introduce one term for you which is called area vector. You know it is called area. So what is the definition of area? You can see in my hand, you can see one duster, right? This duster is something like a rectangle piece. So length will be there, breadth will be there, height will be there. So this duster will have a top surface will be like this. You can see this surface, and this will have the small surface will be here, and this black surface is also will be here. So area means normally we are finding the area length into breadth. We are multiplying length with the breadth will get area. So what is called area vector? If you are considering the top surface, this spongy surface, if you are considering, then area vector is always perpendicular to the area. So now I am placing the pen like this, perpendicular to this spongy surface. So my pen needle, the nib is directing towards top side. So this is my area vector. In another way, I can also have an area vector like this. Now this pen is making 90 degree with the surface. Here also it is making 90 degree with the surface. So area vector is a term which we are going to learn new term today, and that is called area vector, and that area vector is always perpendicular to a plane surface. So if you are taking any surface, then the area vector is perpendicular. This is a concept will be here. So area vector is always perpendicular to the surface area. Okay, let me represent the term. So area vector, write down the heading on your notebook, area vector. You can pause the video and you can write down after the notes is done. I mean the lectures in the area will be done. Once it is done, you can also note down. So I just have an area like this. So this is a surface area. This is like a sheet of paper you can consider, and which is lying on the x and y plane, and which is lying on the x-axis. Now the area vector is straight upward, which means with respect to the surface, this is making 90 degree, and this is called area vector. I can put it as vector A. Okay, so hope you remember the term called area vector. Area vector is a vector which is pointing the perpendicular to the surface area. In what area I am considering, whether it is a rectangle area, whether it's a square area, or whether it is a spherical area, whatever. So if you can draw a perpendicular line to that surface, then that is called area vector. Here this is an area vector. Another way, if I am taking I can say like a spherical surface like this one. So this is an area vector because this is making 90 degree. This is an area vector to this point because it's making 90 degree. This is an area vector to this point. This is making 90 degree. This is an area vector to this point. This is making 90 degree. So at every point on this circle, I can draw a line which is going outward, and this is called area vector. Okay, hope you understood what is called area vector concept. Okay, next. So with this understanding, we are going to learn the term called electric flux. So we are going to define what is called electric flux. Electric flux is nothing but number of electric force lines, or also we call it as number of electric field lines per unit area, which means how many number of field lines are causing in an area. Suppose I'm assuming I have a surface like this one. So I placed some charge will be here. So because of this charge, either here or it is very far away, electric field lines are going like this. So this electric field lines are like this one, and the area vector to this area is outside. So area vector is outside. Okay. So here electric flux simply indicate number of field lines are passing perpendicular to the surface. Because we need to have a three-dimensional understanding for this one. For this one I am explaining. You can consider this is a duster. Here this is a spongy surface. Correct, this is a duster, and towards me it's a spongy surface. Now if I have a charge here, what will happen? This charge will produce electric field lines, and this electric field lines are coming into this point and going out of this one. Okay, and these things are called it as a electric field line. So suppose if you are assuming this is like 1 meter square area, I know this is more than 1 meter square area or less than, that doesn't matter, assuming this is 1 meter square area. Now the electric field lines are coming like this and passing into the surface and going with the other side. So how many number of lines are crossing this area? Suppose I am assuming 1 line, 2 line, 3 line, 4 line. So 4 lines are going into the duster and coming out of the duster. Then that is called electric flux. Okay, so flux is in very simple way number of electric field lines per unit area. In 1 meter square area, how many number of electric field lines are passing? That count here it is called. Here, suppose if this the surface area, the area vector is like this, electric fields are like this. Now here you can see 1, 2, 3 lines are passing, and these 3 lines are called electric flux. So flux means number of electric field lines are passing per unit area. Okay, hope you understood what is called electric flux. Let me take a couple of examples so that it will be clear. Okay, let me take a cylinder like this. Okay, suppose I am assuming the electric field lines are like this. So this is the direction of electric field lines. I placed a cylinder like this. Now with respect to this, we have a different electric field lines will be here. Different means 3 electric field lines will be here. So we have how many surface? We have a curved surface S1. Here also curved surface S2, or I can say it's a plane surface. Okay, this is a curved surface. This surface is called this surface is called S3. So we have totally 3 surfaces will be there. All the 3 surfaces together will form the cylinder. I need to draw the area vector. Area vector for the S1. Always the area vector is going away from the surface. So S1 area vector is like this. S2 area vector is like this. S3 area vector is perpendicular to the surface. So this is S3 area vector. Okay, so now what is called flux? Flux is normally representing using a letter called phi. This is what is given here, flux phi. Phi is equal to dot product of electric field into area vector. This is the definition of flux. If we have replacing the dot product, then what we will get it will be here. We will get it flux phi equal to dot product means we can say EA cos theta. Theta is the angle between. Theta is the angle between what and what? Electric E and A. E is called electric field and A is called the area vector. So that angle is called theta. So we have totally 3 flux will be there. So I can say total flux will be equal to phi 1 plus phi 2 plus phi 3 because 3 surface will be here. So 3 flux will be here. What is phi 1? EA cos theta. So EA cos theta. Angle between E and A for first the surface. So electric field lines are going like this. Area vector is like this, opposite. So at this surface is what? Electric fields are going right. Area vector is towards left. So what will be the theta value? 180 degree. Second one. Phi 2. Phi 2 means this surface. Electric field is like this. Area vector is also like this. Both are in the same direction. So what is the value of theta? Theta equal to 0 degree in this case. And the third surface S3. So electric fields are like this. area vector is like this. This is that area vector. So the area vector is like this. Electric fields are like this. So what is the angle will be here? 90 degree. So it is EA cos of 90 degree. EA cos of 90 degree. What is cos 180? Minus 1. So minus EA. What is cos 0? 1. So plus EA. Cos 90 0. So what this indicate? Equal to 0. So which means total electric flux over any closed surface is equal to 0. Okay, so this is I just taken as an example, and this example indicate it is a closed surface. So for any closed surface, the electric flux will be equal to 0. If you have taken any surface, anything, the closed, the overall area, which will leads to a 0 concept will be there. So total electric flux over a closed surface is equal to 0. Total net electric flux. Net means what? Net means the total surface I am considering. Here it is a cylinder, and that cylinder will have 3 surface will be there. 1, 2, 3, 5, 1, 5, 2, 5, 3. So total flux always for a closed surface will be equal to 0. This is called Gauss's law. Okay. Here I am considering, here you can see within the surface, any charges are present? No charges are present. Okay, now we will see another example, a surface with charge. You can pause the video and you can write it. So total electric flux. So the final assumption, the final point from here, phi total equal to 0. Provided, we'll write a condition, provided no charge within the closed surface. No charge within the closed surface. This is a closed surface, and that closed surface doesn't contains any charges. Charges are outside of the surface. In that cases, the total electric flux will be equal to 0. Okay, we will see what will happen to the flux if you have placing one charge inside. Okay, so we'll see that session. What will happen if you have placing one charge inside of any closed surface? Let me take an example. Suppose this is a closed surface, it's a closed path. I placed one charge will be here Q. At this point, the area vector is like this. This charge will produce electric field in all directions. So at this point, electric field like this. At this point, electric field like this. At this point, electric field like this. So this charge will be produces electric field in all direction. So with respect to this point, I am applying the Gauss's law. So Gauss's law, phi will be equal to E dot A, which is equal to EA of cos. Electric field and flux both are in same direction. So what is the angle between them? 0 degree. So phi will be equal to EA in this case. Okay, but here this is for hold the complete surface. For all the complete surfaces, if you have taken, this is called phi is equal to E into A. So E means what? 1 by 4 pi epsilon 0 Q divided by, suppose I am assuming the radius is R. So it become R square into multiplied with. What is area of the spherical surface? Area will be equal to 4 pi R square. 4 pi R square cancel. So what will come? Q by epsilon 0, which means my flux will be equal to Q by epsilon 0. Here we have a conditions. What is the condition? Provided a charge is placed in a closed surface. Whenever if we have placed a charge in a closed surface, then flux will be equal to Q by epsilon 0. If you have not placed any charge in the closed surface, in our previous example, we have a cylinder like this. We told electric field lines are going like this one. We just told like this one. Here also electric field lines are going. But when we look into this sphere, charges are present. When charges are present, it is called Q by epsilon 0. When charges are not present, the total flux in this case will be equal to 0. Okay, so by combining these two cases, what is our famous Gauss's law states that? What is our famous Gauss's law state that? Gauss's law states that this is for a complete flux. So if you have a small area, then total electrical flux equal to integral. Integral, I am putting a circle. This circle indicate closed integral, which means this law is applicable for a closed surface. Here I am writing E dot dA. dA is a small area. If you are integrating the full thing, we will get complete flux. So E dot A. So if you are integrating dA, we will got EA. So you can write phi is equal to EA also. But if it is a small area, we will put dA and we are integrating. E dot dA will be equal to what will come? Q divided by epsilon 0. This is called Gauss's law in electrostatics. Here for better understandability, I am putting En will be here, suffix En, Q enclosed. Okay, what I'm trying to say for here it is for enclosed means the charges are present within the closed surface. In this case, charge is present Q, so it is Q by epsilon 0. In this case, no charge is present, so flux will be equal to 0. Let me take one examples to you. Can you tell me, if I have a surface like this, I have a charge Q1, I have a charge Q2. What is the flux in this case? Two charges are there, not only one charges. This is like summation of the charges in that case. So sigma Q enclosed. You will not see this sigma sign maybe in majority of the books you are referring, but I would like to keep it as sigma. Some reference book is also mentioned this sigma also, so doesn't matter. It's only include number of total charges. So how many charges will be here? So here total flux will be equal to this. I cannot calculate. I can calculate this area. All are equal. So total flux will be equal to charges are enclosed within the surface. Q1 by Q2 by epsilon 0. This is called a flux. Let me take one more examples to you. First, next example. This I will give it as example number 1. This I will give it as example number 2. Let me consider I have a sphere like this. Now, within the closed surfaces, I placed a dipole which are separated by a distance of 2L. What is the flux produced by a dipole? Dipole means two charges equal and similar charges which are separated by a shorter distance in this case. Right, shorter distance. So in this case, what is the summation of the charges? Q plus minus Q. So what will come? Total charge Q plus minus Q whole divided by epsilon 0, which means 0 by epsilon 0. Your answer is 0. Okay, so if it is a dipole, one dipole, then it is 0. If it is some other charges like this one, then you have to add with this help of this one. So this is called Gauss's law. This is very, very important. Closed integral E dot dl. Why we are saying closed? Okay, if somebody will come and write an equation like this one, just okay, E dot dA. This is called open integral. Open means surface is not closed. If surface is not closed means Gauss's scientist saying, hey, you cannot use my law. You can use my law only if you have a closed path. If you have no closed path, you are not supposed to use my law. If you have a closed path, you can use my law, and this is phi is equal to E dot dA. E dot dA, you can expand it and write it as EA cos theta equal to summation of the charges divided by epsilon 0. This is something called Gauss's law. Okay, so Gauss's law, it's quite important for your board examination point of view and your school examinations point of view. So wherever you go, this law is important. Okay, we'll see some of the examples which are related with the Gauss's law. Okay, some examples in the sense, some of the problem wise questions we'll say with respect to Gauss's law. Okay, so learn this Gauss's law for your school board examinations point of view. It's also important. 5 marks questions are normally coming from this area, and for Neet entrance examinations or JEE examinations point of view, there are some application based questions are also coming. Hi, we'll move to the next topic, and which is related with electric flux over a cone. Now we have learned about Gauss's law in electrostatics, which is called Q by epsilon naught. total flux equal to E dot dA divided by Q pi epsilon naught. Q is the total charge enclosed within the surfaces. If charge is not there, we can say flux will be equal to 0. But in this case, we are going to learn electric flux over a cone. There are less chance to ask these questions for the board examination, but there are high chance to ask the same questions for same topic for your entrance examinations. So we'll see what all the things are included in this areas. Okay, so electric flux over a cone. So we have to draw a cone surface. So we have a cone and equally placed, it's like our normal cone ice cream, right, that you are more familiarized. So we placed one charge will be here. So what will happen? Electric field lines are passing like this. Electric field lines are passing from this cone surfaces, and this is called electric field lines. So here we are assuming the surface will have a radius of r and which is at a distance of x meter away. Next, what we are going to do means we need to find out the electric field lines which are passing over the surface. So to find that, we are considering a ring, a small ring which is at a distance of r dash from here, and its radius is r. This area alone I am drawing will be here. So here this is the direction of electric field, and here I am considering a small area which is called dA, and the area vector is perpendicular to the surface which is called dA. Angle between area vector and electric field is theta. This is an horizontal line, this is some slanting line. So this is an horizontal line, this is some slanting line. So this angle is also called theta. This area alone drawing will be here, something like this one. So here it is small r, just zooming it out, and this is x and this is r dash, and this angle is called theta. This is for a smaller circle. For a bigger circle, what is the radius of the bigger circle? Capital R. We are going to measure what is the total flux over this surface area for a cone like structure. Okay, so we know our integrations, closed integral E dot dA, or we can say EA cos theta. This is called total flux. We are going to calculate the total flux will be here. So closed integral, we have a closed integral. What is the value of electric field intensity? 1 by 4 pi epsilon 0 q divided by r dash square, distance from here to here, r dash square into dA. dA means for this small piece of ring, this small piece of the ring we are expanding, and we are getting a red color full ring. So for this blue color ring alone, if I am drawing like this one, then I'll cut it here and I will place it like this. Its length is called 2 pi r, because radius is r means, if radius is r means, this is always required in physics. If radius is r means length is 2 pi r, breadth is dr, always remember. So area will be equal to length into breadth, which means 2 pi r into dr, always in physics. Okay, this is not only in physics, this concept is also required in physics, but it's a concept from mathematics. If you have a ring, if you cut it and put it in a straight wire, its perimeter is equal to its length. So L will be equal to 2 pi r dr, and dr is called breadth. Area will be equal to length into breadth. We are substituting here. So 2 pi r into dr. What is cos theta from this diagram? Cos theta equal to adjacent side by hypotenuse, which means x divided by r dash. X divided by r dash. Now we are going to substitute the values, whatever we got it here, we are going to substitute here. Okay, so closed integral here, 4 pi get cancelled, 4 pi and 2 pi will get cancelled. So what is coming balance extra? 1 divided by 2 epsilon 0 will be there. Okay, and q r drx in the numerator. So q r drx in the numerator. Denominator r dash square r dash. So it is r dash cube. What is r dash from this diagram? R dash is an hypotenuse. So we can apply Pythagoras theorem. So we'll substitute 2 epsilon 0. Don't forget the integral. Integral everywhere, starting from here, integral. Okay. So it is closed integral. So closed you can place it. Anyway, simply it's an integration. Closed only going to represent it's a closed surface. So first level you can put it, later you don't want to put it because you already know it's a closed surface. So you can either place the circle or not. Okay. no issues. But while writing the first set of equation, this is Gauss's law. Here you have to put a circle because this indicate Gauss's law is applicable only for a closed surface. After that, no problem. So 1 divided by 2 pi epsilon 0 and QR dr into x. What is r dash? R dash equal to r square plus x square. So r square plus x square whole power 1 by 2 is called r dash. So 1 by 2 and 3. So what will come? 3 by 2. Okay. Now let me take I want this to be integrated. To integrate that, I am taking t square equal to r square plus x square. Both the sides I am differentiating. So 2t and dt. 2t dt will be equal to 2r into dr. With respect to r, I am differentiating, not with respect to x. X is constant. So constant, it is 0. Okay. Now if you see, will be here. It is called small r. This is for a small circle. I need to for a bigger circle. To have it for a bigger circle, from small r to I have to go to capital R. Starting from 0, I have to go till capital R. So what should I want to do? I have to integrate. So this is what I am doing, an integration, but at the same time, what is a varying parameter? R is varying parameter, all others are constant. So all constant terms are take it out of the integration. So integral 1 divided by 2 epsilon 0. Numerator q and x is constant, so q and x will come out. Integral will be equal to r dr divided by r square plus x square whole power 3 by 2. So we can say qx divided by 2 epsilon naught will be equal to, what is r square plus x square? T square. So t square 3 by 2 means what will come? T square 3 by 2. 2 and 2 will get cancelled. So it becomes t cube. If you are placing t square will be here. This is t square. So t square 3 by 2. 2 and 2 get cancelled. It becomes t cube. What is coming in the numerator? R dr. Here 2 and 2 will get cancelled. R dr equal to t dt. Correct. So R dr I am substituting t into dt. Here I have to integrate. From where to where integration? 0 to capital R. 0 to capital R. Okay, 0 to capital R we need to integrate. T and t will get cancelled and in the denominator you will get t square. I am clearing this area. You can stop, pause the video and you can complete the notebook. So let me go further to get our final results. Okay. So qx divided by 2 epsilon 0. We are integrating from 0 to r 1 by t square into dt. We know integral t power n equal to t power n plus 1 divided by n plus 1. So same concept applying will be here. Qx divided by 2 epsilon 0. T power minus 2 plus 1 divided by minus 2 plus 1. Integration limit 0 to r. So qx divided by 2 epsilon 0. Here minus 1, take it out, will be here. So it is called 1 by t. I have to apply the limit 0 to r. We are moving forward. So minus qx divided by 2 epsilon 0. What is 1 by t? T means r square plus x square. So which means r square plus x square whole power 1 by 2. We have to apply the limit from 0 to r. We are applying the limit. So minus qx 2 epsilon 0. Upper limit minus lower limit. Instead of small r, we are substituting capital R. So 1 divided by r square plus x square whole power 1 by 2 minus substituting 0 1 divided by x. So 0 plus x square. So x square. X square and 1 by 2 will get cancelled. So it become 1 by x. We got it. Now this is minus sign. This minus sign I am multiplying to inside. So this minus and this minus become plus. X and x will become cancels. So q divided by 2 epsilon 0. Multiplying inside, so this minus and minus become plus, x and x will get cancelled. So here it is come 1 and minus of the other term 1 divided by, so x is multiplied, x divided by r square plus x square, r square plus x square, and here in the denominator we have some 1 by 2. So this is a final formula. We got it for this one. So you can pause the video and you can complete these steps. I'm cleaning this right hand side. Okay. So this is what the formula we got, q divided by 2 epsilon 0 1 minus x divided by r square plus x square whole power 1 by 2. If you look into our the diagram what we have drawn before, what I have drawn before, our diagram is look like this one, right? It's a cone and this is at a distance of x meter away and radius is r. So if you are looking to this diagram and if this angle is theta, okay, I told for a small circle this angle is theta. Now for a bigger circle means for a bigger area this line will shift to here. So what is cos theta from this diagram? X divided by hypotenuse. So x divided by hypotenuse means this side. This side means what? X square plus r square. So x square plus r square whole 1 by 2 or root. So this term is actually what called? Cos theta. So this formula in another way also you can write q divided by 2 epsilon 0 1 minus of what is coming? X pi. So 1 minus of cos theta. So this way also you can represent the formula. It's not only in one format, so two format. This is actually a cos theta that we are represented and we have put this equations. So this is very important, as I told before, for entrance examination, board examination point of view, chances are less. So understand this is an electric flux over a cone, okay. So for a cone this will be the electric flux. Let me take another example and I will ask you one more questions. For example, okay, I have a cylinder, okay. So if I placed one charge q will be here, then the total flux passing through this cylinder, complete cylinder, total flux equal to q by epsilon 0. Q by epsilon 0 is the total flux. But now here we don't have, now what will happen if I am taking an half cylinder, so charge will be here. What is a flux? So this is for a full cylinder. For a full cylinder, the flux will be equal to q by epsilon 0. So flux will be equal to q divided by 2 epsilon 0 for a half cylinder. For a full cylinder, it is q by epsilon 0. For a half cylinder, it is q by epsilon 0. The same question can ask like in a full circle, in a full sphere, I can say in a full sphere, it is q by epsilon 0. If I am taking a half sphere like this, so what is the flux for this one? Q by 2 epsilon 0. These are the small minor things, but note down on your notebook. Whenever full sphere, q by epsilon 0 is coming. Whenever we are cutting into half, the flux is also dividing to half. Okay, so based on this concept, there are few questions may come with respect to cube. We will see that is also under our special cases. Write down the heading, electric flux over a cube. Electric flux over a cube. The next heading, electric flux over a cube. Electric flux over a cube. We'll see electric flux over a cube. Listen very carefully. Okay. So we have a cuboid or cube-like structures like this. We have a cube. Okay, so what I'm assuming like here I need your three-dimensional imaginary power. Okay, if you have placed one charge in the center of the cube, then what is the total flux passing over the cube? Q divided by epsilon 0. This is something called the total flux. Total flux where how many surface will be there for a cube? In the side wise we have 4, top and bottom. So totally for a cube we have 6 faces. 1, 2 surface will be here, and 1, 2 and 3, and we have 4. So the front surface is 1, side 2, 3, 4, and we have totally 4 surface, bottom surface 5 and top surface 6. So totally for 6 surface. For a 6 surface, total flux for how many surface? How many? 6 faces, I can say. For 6 faces, this one. So what is the flux for one face? For one face, total cube will have 6 faces, which means q by epsilon 0. For one faces, how much will come? 1 phases means 1 by 6th of total flux, because 6 phases are there. So Q by epsilon 0. This is for one phase. Okay, this is one example for total flux over a cube. So here I have placed a charge will be here. Now instead of placing the charge will be here, let me take another example. I have a cube like this, like this, like this, like this. Now if I placed one charge at any corner, if I placed one charge at any corner, the same question, what is the total flux, okay, total flux over a cube? This is one of my question. And my another question is, what is the total flux over a surface, over a face or surface, anything over a face? Two things. In this case, if a charge is placed at the center, total flux over the complete cube, over a cube, is Q by 6 epsilon 0. So this Q by 6 epsilon 0, Q by epsilon 0 is covered for 6 phases. So 6 phases are sharing this one. What is the share of one phase? Q by epsilon 0 into 1 by 6 times. Now instead of placing here, we are placing at the one corner. In that case, what will happen? What is the total flux over a cube? What is the total flux over a surface? In this case, in a cuboidal structure, okay, you can assume like we have divided this cube into 8 pieces, or you can assume like that in another way. Listen very carefully. We have a cube, the same cube I am drawing repeatedly again here. So this is one cube and this is one cube. Now here, listen very carefully, you have to imagine a 3D way. Here I am placing my charge Q, right? So this will be shared with another cube like this. So here we have a cube, right? Here we have a cube, and this will be shared with this is one cube, and here in this side also we have another cube, and in this side also we have another cube. So totally the one cube which is placed or one charge which is placed at the corners are shared by how many cubes will be there? Here on the left side we have one cube, on the right side we have one cube, and here we have our third cube, and in this bottom left we have 4 cubes. So 4 cubes are there in one phase. The same thing is available on the back side also. Okay, same things are available on the back side also. So totally if you are placing one Q will be here for the to cover the complete Q, to cover this Q, there are totally 4 cubes are there in one phase. Okay, totally 4 cubes. This was total 1, 2 and 3 and 4. So like this. So these 4 are the cubes which are shared by one Q in the front side. Same way will be there in the back end. We cannot draw. It's very difficult because it's a 3-dimensional pictures, right? In one side you can see from this diagram, in one side we have one cube like this, and we have the another cube will be like this. So second cube will be here, and we have a third cube is like this. So we have totally 4 cubes are shared this Q in the front side. Similarly back also we have another cubes will be there. So totally this Q, the total flux is shared by 8 cubes. So total flux, which means 8 cubes. What will happen to my pen? 8 cubes. Okay. So 8 cubes flux will equal to Q by epsilon 0. So 8 cube equal to epsilon 0. So this charges is shared by 8 cubes. So what is the total flux over 1 cube? Yes, now you know 1 by 8 of Q by epsilon 0. 1 by 8 of Q by epsilon 0. What is the total flux over a surface? You will say, sir, for 1 cube it is 1 by 8 Q by epsilon 0. This is for 1 cube, and how many phases will be there? 6 phases will be there. So for one phase means 1 by 6. You will say 1 by 48 Q by epsilon 0. Pakka wrong answer. No, not correct. For 1 cube 1 by 8 q epsilon 0, it is correct because this q is shared front side by 4 cubes and back side by 4 cubes, totally 8 cubes, cube by 8 epsilon 0. So for 1 cube 1 by 8 into cube by epsilon 0. But for one phase in this case, it is not, you cannot multiply it with 1 by 6 as we have done here. Why? Reason is quite interesting. So this is wrong, we cannot do like that. Okay, we cannot do like that. The reason is like, I'm drawing again here. The reason is like, if we have a cuboid structure like this, if we have a cuboid structure like, if you're placing the charge will be here. Now I know the contributions to here, it is 1 by 8 q by epsilon 0 is a flex which is coming. Now I am drawing the flex line. So the charge will produces electric field lines like this, electric field line like this, and electric field lines in all over the area it is facing. So with respect to this area, suppose you assume for the upper surface, what is the area vector? Area vector is like this. Electric field lines are grazing over the surfaces. So what will be the total flux? E dot A of or EA cos 90. Theta is an angle between electric field and area vector. Cos 90 means total flux equal to 0, which means this surface is not taking any flux. Similarly, this surface, electric field will be like this, area vector is like this. So what is the flux will be equal to EA cos 90. So no flux is not taking by this surface. What all the surfaces are taking the flux? Here this surface will take flux because for the bottom surface, I will just shade this bottom surface. For this bottom surface, electric field lines are passing like this and area vector is like this. So this angle is not 90 degree. So this surface, C1 surface is valid. C2 surface is valid. Okay, so C1 flux should not be 0, C2 flux should not be 0. Then what are the other surfaces? The back side surface 0, top side surface 0, this side surface will be 0. So 3 surfaces also gone. So how many surfaces? So this surface 0, the top side surface 0, back side surface also, and electric field lines into this one. So 3 surfaces will be gone. Now we have a 3 surfaces are available. So top gone, this side is gone, and we have the bottom surface and we have the front surface. Okay, so we have the bottom surface is available, side surface available, and the front surface. So C3. So totally the flux given by 1 by 8 q by epsilon 0 is the flux from the cube that is available, and that flux are used by totally 3 phases. The top surface E dot A cos 90 0, this side surface E dot A cos 90 0, and this back side surface, totally 6 phases will be there. Back side surface, electric fields are going like this, area vector is into that. So that is also cos 90. So totally 1 by 8 q by epsilon 0 will be shared by 3 phases, not 6 phases in this case. So what is the total flux over a phase means 1 by 8 q by epsilon 0. Totally how many phases are sharing? 3 phases are sharing. So one phase the contribution is 1 by 3, which means 1 by 24 times q by epsilon 0 is the right answer. Okay, so 1 by 8 q by epsilon 0 into 1 by 3. This is a total flux over a cube when a charge is placed at the corner, at any one of the corner. And total flux over a phase equal to 1 by 24 epsilon 0 if charge is placed at any one of the corner. If charge is placed at the center, if the charge is placed at the center, then it is 1 divided by, q by epsilon 0 if charge is placed at the center. So I will give you a challenging question. Okay, you can think about that and you can come with some answers, or it is a thought process I am giving. So 2 things we have learned. Charges are placed at the center. So total flux will be over a cube equal to 1 by q by epsilon 0. Total flux over a surface equal to 1 by 6 epsilon, 1 by 6 times of q by epsilon 0. If the charges is placed at any one corner, then the total flux over cube equal to 1 by 8 into q by epsilon 0. Total flux over any one surface equal to 1 by 24 into q by epsilon 0. Now I am giving a challenging question. If I am placing if I am placing a charge not at the center, not at the corner, instead I am placing the charge at any one of the surface. If I am placing charge at any one of the surface, I have two questions to you. This one, total flux over a cube is how much? Total flux over a face is how much? Now we are placing a charge over a face. Over a face means, let me draw a diagram for this one. So this is a diagram, cube. Okay, so you can assume I am placing a charge at the top surface. So what will happen in this case? The similar to this corner, you have to remember, okay, there are one cube top side, one cube side, one cube will be here, one cube other side. So how many cubes are sharing by this charge? In this case, how many cubes are sharing by this charge if it is placed at the corner? Front side 4, back side 4, totally 8 cubes are sharing. That's why for whole system it is 1 by 8 times of q epsilon 0, q by epsilon 0. For one cube it is 1 by 8 times of q by epsilon 0. Similarly, instead of placing at the corner, I am placing at any one of the faces. If it is placed at any one of the faces, what is the total flux over a cube? It's a challenge to you. And total flux over any one of the faces, what will happen? You have to come up with an answers. You can discuss with me or you can comment it down. Yeah, you can think about this one. Okay, this was the point for today's sessions. Okay, so thanks for watching and have a great day. Thank you. Bye bye.